Electrical and RF safety. That's where we go, the exposure calculations, although there's a whole lot more detail on the general exam than there is on this one. A couple things on hazardous materials and a little bit on grounding. So the most common danger in ham radio, especially, is from lightning strikes or nearby strikes. I guess if Sandy was here, he could attest to that.
That's right.
So one of the things that you need to do definitely is have an external earth ground tied to your single point ground for all your equipment. So what's the primary function of an external earth connection or ground rod?
Yeah, lightning protection.
In Florida, that's important.
Yeah. If you ever look at, what is it? Lightning Maps, I think it is the name of the site. And it shows the lightning strikes in, it's always red around here, these little circles. RF exposure, and they've been making some apparent changes here recently. And I know they changed in the most recent general exam some of the questions. And it was my understanding that now
you always have to do that.
They require it for anything over a milliwatt, which basically means you got to do it for anything.
If there's
A hotspot
static
isn't
discharge,
over a milliwatt.
static discharge when you hook up your cable.
So, you know, they have this term, specific absorption rate, which is the rate at which your body absorbs energy at different frequencies. And it's the soft tissue that's the problem, things like your eyeballs and I guess your brain. And they're kind of important. My understanding that you can actually, it's like frying an egg. If you get too much RF exposure, you can just turn your eyes white. And I don't know that they can fix it. So what does SAR measure? I kind of like synthetic aperture ratio.
Yeah, I think that's a cool one.
But it's not. It's
I think it's Charlie.
synthetic aperture radar.
Yeah, that's what I'm.
I know.
Charlie.
That's why I like synthetic aperture ratio. But I would go with Charlie.
Yeah.
Okay. So the FCC, in conjunction with the ARRL and the IEEE, and might even been somebody else involved. Well, yeah, the National Council on Radiation Protection has come up with this chart of maximum permissible exposure limits. And it looks like they're starting to make changes to it, where before it was just milliwatts per square centimeter was the exposure level. And they had a controlled and uncontrolled environment. Uncontrolled was your neighbors who don't know you're radiating them. And it was 0.2 milliwatts, where the controlled was 1 milliwatt in the 30 to 300 range. Now they're throwing in, but I don't have any real specifics, the E field and the H field separately, and they're different levels. So I'm not sure how that is going to affect things.
Are they going to provide us downloadable software for this?
Well, there's a calculator on the ARL website, and I'm sure there's others. You just plug in your antenna gain, your power,
And it
frequency.
spits out the report.
Yeah. And that's all you need to do, but you need to do it for every combination. If you got different antennas
Right.
or
So
different
this is on
radios,
what website?
ARL. Yeah.
Yeah.
And I don't think you have to be a member to use that. I'm not sure.
Anybody, that's free software, you can get it anywhere.
That's a requirement though now, so.
You have to do it. They don't specify, there's multiple ways. And you can use a field strength meter and do it. Although a calibrated field strength meter isn't going to be easy to come by. It would be kind of difficult. It's a whole lot easier to plug in 4 or 5 numbers and print it out. Although you're, according to the rules, you're supposed to have it in your shack in case the FCC comes by and inspects you. I don't know, has that ever happened?
I've never heard of it.
They threaten though.
Never even heard it threatened.
Oh, all right. Here's the
Yeah.
kind of updated chart where in the past, it was the black line here in the middle and the dotted line, which is the uncontrolled. But now they've got this E field limits and the H field limits below 100 megahertz. So I'm not sure. That's really all I know about those, but they are making some changes.
It used to be like, if you were operating at like 40 meters, you would be able to go 100 watts and no requirement was necessary. And then you get up to like 50 megahertz and it's 50 watts with nothing. But
Yeah.
if you go over 50 watts at 50 megahertz, then you require a report. But
Well-
you're saying now it's like everything, so.
You have to do the, it's my understanding, you have to do the calculation, oh, well. You have to evaluate your exposure.
Right.
However you do it, and they list, not here, but on the general, they listed 3 different ways to do it.
If you have your HF antenna up 20 feet, you don't really have to worry too much unless you're running
Right,
one hell of a lot of power.
yeah, even 1,500 watts, you're probably all right.
Yeah,
Although, you still have to do the,
I calculated it in my mind.
but if you got a beam antenna and you're directing it at your neighbor,
That's his problem.
no, that's your problem. Anyway, the basic chart is this 1 milliwatt and the 30 to 300 range, which is where human tissue is most sensitive. Oh, gee,
See,
you think it's C?
yeah, pretty sure.
Okay.
Final answer.
I don't know anything about microwave myself, but when you start getting up in the microwave ranges, even though the exposure level is a lot higher, acceptable exposure, it can cause some serious problems. So I guess those people screwing around with waveguides and stuff at the microwave and high power, or walking in front of
I
a
know when
radar
we
when it's
were-
on, like,
I was stationed in San Francisco. We couldn't use some of our microwave or actually they're tracking radars, right? Pointed over towards Oakland because it was dangerous for the people over there. Of course, that was like a megawatt or so.
yeah,
Well, they have like those
With
weather,
beam.
weather radars are like, aren't they up at like 2 gig?
Yeah.
They sweep. So for,
yeah.
you know, there's gotta be an area outside that, it's gotta be directed high enough, but
It's directed up in the air to start with.
Yeah.
but still reflected.
Yeah, you could get some weird propagation and zap somebody. Which of the file or reflection off of the power line? You think you're going this way and you're getting your neighbor behind you.
Yeah.
Which of the following injuries can result from using high power UHF or microwave transmitters?
RF exposure in excess of the MPE.
Yeah, what's one of the potential hazards of operating in the amateur radio microwave bands?
Ionization radiation.
Yeah, previous one, I guess one of the examples that wasn't on there is your microwave oven. And you can see how much heating that does, and that's not very many watts.
That's 1,200 watts.
Maybe,
Microwave,
yeah,
most microwaves.
somewhere, I think mine's only 800 or 900.
Yeah, smaller.
Okay, so this is talking a little bit about the new electric field and magnetic field limits, which I haven't found that they've actually really specified them yet. But apparently there's 3 reasons why they're doing that, because your body reacts differently to the E and H fields. Ground reflections can affect, and the E and H radiation intensity peaks can occur at different locations. I guess that's in the near field. You can have E field greater one physically one spot than the H field is. Fortunately, you only have to know the 3 reasons. So why are there separate E and H field limits?
They mentioned.
Probably all of them.
All of them. Well, we had 3, all the above so far. That's unusual. Okay, so they don't want you to forget your neighbors. So you need to make sure that you're also calculating the exposure for the uncontrolled limits, which is anybody that doesn't know you're radiating, basically. Typically your neighbor, but could be somebody walking by. So when evaluating RF exposure levels from your station at a neighbor's home, what must you do?
Uncontrolled, so. So that, what's the last one?
Yeah, I think Delta.
Trying to fool you with the acronym.
Yeah, I would go with Delta. But I would have been wrong.
Oh, it's exposure versus emission.
Yeah.
That's a tricky one.
Yeah.
One of those you have to read all the answers carefully.
Well, I remember the uncontrolled bit, but I forgot the exposure versus emission.
Well, it's the old thing that, 2 of them you can throw out because it says controlled.
Right.
So you have to figure out, is it B or D? And although,
What about the birds in the trees? I must be just napping with the birds in the trees.
am I reading that right? Is there a,
But I mean, they would be they could be in equals.
these
I don't-
worded the same?
You look both the same to me.
Could be, but most birds around here.
I wonder if that's a typo on my part.
What are you looking at?
A lot less less.
I wonder if they get close enough to feel their
I have to check that one.
body heat.
Hang on just a second. What's the,
Take off.
do you know what the number is?
Yeah. Second. E0A 02. Yeah, I think answer D is got a typo in it. I bet it's supposed to be more than. Which is why I said D was right, because D is worded the same as B.
No, D says emission,
Sure.
MP emission, maximum permissible emission rather than exposure.
Ah, you're right. Okay.
Less than the maximum.
Yeah, no, he's got it. It's emission instead of exposure. I kept reading it, it looked the same. It's definitely one you gotta carefully read.
Don't have to read that question.
That may be on the test from hell.
No, I think this is gonna be ingrained in the brain.
Well, that's the best way to learn.
What's that?
Oh yeah, this is a really weird one. So if you've got multiple transmitters around and the total emissions are exceeding the limits, at least that's the way I understand this, that each of the participants transmitting is responsible if they're doing more than 5% of the exposure. It's not clear to me whether that means they're just 5% or they're 5% of the overexposure. But as far as exams concerned, we don't have to know the answer to that. Just that they're responsible for mitigating the situation. That's something new that I'd never, and I don't remember that from my extra exam, which is the same question pool. When evaluating a site with multiple transmitters operating at the same time, the operators and licensees of which transmitters are responsible for mitigating overexposure situations. Charlie.
So that's just saying if there's a bunch of antennas on the top of a building, whose responsibility is it? If you're putting out 5% or more,
Yeah,
you have to ensure that you're within the right.
It's like over at broadcast court, there's like about 8 transmitters over there.
I don't know.
There's a bunch of them.
Yeah. But they're all repeaters, aren't they?
They're
No.
transmitters, aren't they?
But it's
Well-
talking about the,
Well, that's true because the control operator is still responsible, right?
That's right.
And the licensee.
Mhm. But the antennas are all up, 300 feet, so you really don't
And
have to worry too
I'm
much.
sure that they've done their exposure calculations.
I don't think we ever did.
well,
Don't say that, you're being recorded.
the thing of it is, you have the common mode currents. I mean,
Well, there's a lot of stuff could be going on.
Some of them are commercial sites, so you don't know what.
Yeah. Well,
they
I'm-
have their own regs.
Yeah.
They always have, so.
I'm sure they comply because the FCC would shut them down. Or fine them. Okay, we can have exposure to other hazardous materials. So if you've got a gas-powered generator, as like a backup, it produces carbon monoxide. So you need to make sure. They used to have some questions about make sure it's not an enclosed space and all that kind of good stuff. This one wants you to make sure that you have a carbon monoxide detector to check for carbon monoxide, not smelling it and stuff like that, which you can't really smell it, but usually if it's exhaust fumes, you can smell those. So how may dangerous levels of carbon monoxide from an emergency generator be detected?
You got yellow gas outside your house, you can come on.
Only a carbon monoxide,
Mhm.
because it's odorless.
So
Heavier than air or lighter than air.
heavy.
Yeah.
Cause it,
That's why a combination smoke detector and carbon monoxide detector, one or the other is not gonna work for you.
actually, I take it back.
Depending
Is it heavier? I was
on-
thinking of,
It is-
I was thinking of gasoline fumes because that, one of the regulations,
I know.
like in a garage, you have to have electrical outlets a certain height because the fumes would go down.
Right,
Carbon dioxide is heavy, but I don't know about monoxide.
Yeah. It's gotta be lighter. It's got one less, molecule, right? Okay, we have some other hazardous materials. Beryllium oxide. I don't know what that's used in as an
I
insulator,
have
but
no idea.
what's that? Oh,
beryllium oxide,
when did you retire from from the Navy? What year?
When was I in?
Yeah.
59 to 67.
Yeah, so Ernie retired long before this happened. In 1984, when I checked into Saratoga in shop 5, they were replacing all the screwdrivers and all the drawers because they were made of beryllium. And if you chip the tip while you're putting in a screw, there was hazard from breathing that dust if it happened to get airborne.
yeah,
And I guess they used it, I mean, it's saying here that they're using it as an insulating material, so it's non-conductive. And that would be why they were using it for screwdrivers, but it wasn't very good. I guess it was cheaper than
Huh.
getting stainless steel screwdrivers.
well, now that you're mentioning, I remember back in the old days on Apollo, we had beryllium wrenches for the very purpose of they didn't make sparks.
Yeah,
I think they also use beryllium oxide in the heat transfer paste like you use to put under transistors and integrated circuits and stuff in a heat sink.
Oh, okay.
I'll have to take a look at that.
Yeah, what were those things made of besides the ones in mica? There was a metal kind of one, I remember, for like the TO3 packages.
There's also a paste.
Yeah.
Okay.
That's what he's talking about is paste, I think.
So you wanna,
Basically used to conduct the heat. Not,
Yeah, to sink the heat, but.
yeah, but it's an electrical
electrostatically-
insulator.
Yeah.
It's a heat,
yeah.
It's a heat conductor.
right? And then the other one is polychlorinated biphenyls, which I guess are in some electrolytic capacitors. They're definitely in big power transformers. The ones that blow up on the pole and you see all the
Yeah.
sparks.
And sprays all that PCB all over the place.
That was just oil.
Huh?
It's a special type of oil, wasn't it?
Yeah, but it's got polychlorinated biphenyls in it, whatever the oil is.
Oh, okay.
Yeah, it's not good stuff. So which insulating material commonly used as a thermal conductor is extremely toxic if broken or crushed and the particles are accidentally inhaled?
Early.
So you shouldn't eat beryllium oxide.
Yeah.
You shouldn't.
Read it, you can eat it.
Oh, okay. What toxic material may be present in some electronic components such as high voltage capacitors and transformers?
Polychlorinated biphenyls.
I don't know that I've ever seen a small
Faster.
power transformer that's oil filled.
Yeah, I've never seen it. Only the ones on the power poles.
Yeah.
By the way, carbon monoxide is lighter than air. Slightly. I just looked it up.
Okay.
Not that I know stuff.
What was that?
Carbon monoxide is slightly lighter than air.
Oh,
It will rise.
okay.
Sleep better now.
Stop for a second.